Welcome and hello to all. Good morning or good evening or good night. I don't know what I have to say for all participants to this sprint meeting of Phenolic International. We are very pleased to have some colleagues. The first person that is with me is Antonio Graca from SOGRAP. He is member of the executive committee of Phenolic International. Then we have two speakers that are very interesting speakers. First one is Alberto De Jesipi from the University of Padova, and he will talk about valorization of unripe grape seeds and wine lees. And so the second panelist is Francisca Isabel Bravo Vasquez. And Francisca Isabel has been working on an aspect that is also interesting. It's a valorization, but at health level for wine lees as a new source of antihypertensive compounds. That looks probably also an interesting perspective. So the idea of the meeting is to have the two presentations and then to have some question and discussion, answer, of course, from the two presenters, but also with Antonio, we can manage a little bit the discussion. And so normally, you know that the event is only 1 hour. It's a short event. So feel free during the meeting, of course, to put your question. Like that, we can manage the question during after the presentation. So I think that we can begin, maybe.
Thank you, Pierre-Louis, and good morning to everyone. My presentation will be focused on the valorization of unripe grape seeds, and wine lees as innovative enological additives and food ingredients. We know that the valorization of byproduct is a topic strictly linked with the sustainability issue. Sustainability is defined as the meeting of the needs of the present without compromising the ability of the future. And from this definition that is from the United Nations, we can see that it does not include only the environmental issue, but also involve all the layers of the society and economics. From this definition, the United Nations developed the 17 Sustainable Development Goals, which include and try to summarize what is the direction that has to be taken in each sector. Focusing on our food and beverage sector, we can simply summarize this path that includes the input, which can be raw material, of course, energy, natural human resources, in order to have some output, which are not always good, like the emissions, in which we can act in trying to reduce them, or using new and more sustainable energy sources. Of course, our companies produce goods, which we can try to make them more sustainable, acting on the supply chain. But the third output are the byproduct. Byproduct, which can be considered sometimes waste to be disposed of, or even resources that can be valorized, so to increase the value of this byproduct following a business opportunity which should be completely sustainable. With focusing more on the winemaking sector, we can see that the amount of human and natural resources involved in wine production are significantly high, and this is reflected also on the and carbon footprint of this supply chain. Starting from the vineyard, we have wine shots and unripe grape, and moving to the cellar, grape stalk, grape skins and seed, wastewater, and wine lees. You can see from these volumes that how is significant the number of products that do not end in a glass bottle. So for all this byproduct, the wine industry already developed and applied some sustainable valorization strategies, including the distillation, the extraction of valuable chemicals and components like polyphenols and acid, the production of grapeseed oil, and the production of energy. Some other ways are less sustainable and more a way to reduce the cost, like land spreading, and then the last option is always the disposal, which is it represents a cost for the different producers. In this presentation, I will focus more on unripe grape seeds and wine lees, trying to show you some study that in Padova we conducted to face this problem. The first byproduct, unripe grape, derived from grape thinning, which is a practice that is done particularly in some regions to enhance the ripening and produce high quality wine. The waste, the residues of this practice are grape, the unripe grape, which they can be composted, but in many cases they are used to produce the verjuice. Verjuice, it's a general name, but we know that different products with similar production scheme are produced in every winemaking region. So for this reason, it's difficult to give a full characterization of this unripe grape juice. But we can try to summarize its composition, saying that its pH is very low, almost always below 3. And in the pool of acid, we find malic, but the total absence of acetic acid, that means no volatile acidity and no vinegar taste. We also have a lot of polyphenols, including caphtoric acid, which is the main one, and also quite a lot of sugars. Here, the range is very variable, but the important thing is that the sugars is the main reason why we have to use sulfides to stabilize this product, because with this amount of sugar is strongly limits its shelf life. Also the price, an important aspect, because the price is quite high, between $8 and $35 per liter. In this, regarding this byproduct, I'm presenting two studies developed by Amadou Pasdematos and Professors Curioni, Marangoni, and Vincenzi, in which, in the first study, verjuice was used as seasoning agent in a salad and benchmarked against lemon and vinegar. The evaluation was mostly done through a consumer test, in which the vinegar remained the one that got the main score, but the verjuice had an equivalent liking to the lemon juice. This allowed to hypothesize a possible application of this juice as seasoning agent, particularly for that number of consumers that dislike the vinegar taste or the taste of acetic acid, which are few. In the second study that I'm going to show, verjuice was used as acidifying agent in production of pickled cucumbers, and compare this time with vinegar, two different dilution of verjuice versus the vinegar. Here we had mostly an overlap in terms of sensory and chemical characterization of the final cucumbers. So relatively to this study, we can say that verjuice is a valid alternative to the vinegar. And in some occasion, the cucumbers prepared with this unripe grape juice were perceived by the panel as less acid, less pungent, and less astringent compared to the ones prepared with the vinegar. The second byproduct that we are going to see today are the grape seeds, which normally are distilled along with the grape skins, and then after the distillation, they are separated for the production of a valuable extract like grapeseed oil and some polyphenols extract used in the pharmaceutical sector. This valuable production also yield some other residues and byproduct. Normally, this solid fraction made of lignin, protein, and polysaccharides, which is normally burned for energy production, but that in the work that I'm going to show you was seen as a possible new source of protein to be applied in winemaking. And this is the focus of first study by the group of Professor Vincenzi and Curioni, in which a novel extraction technique was developed for extract grapeseed proteins from the exhausted grape seeds after production of grapeseed oil. And this extract was suggested as fining agent, and this application would be particularly interesting because it would be the first endogenous additive, first fining agent endogenous to grape, and then plant-based. It was also emerged as allergenic free, which is not the case as other animal-based fining agent, and it can also clean label because grape seed protein can naturally be present in wine. The approval by the OIV is still in progress, but this is based on solid experimental data, which are present, for example, in this second publication, in which the grape seed protein extract was largely tested, evaluating different wines and comparing its activity with the one of different commercial fining agents from both plant and animal origin. Also, different doses were tested, and we had different results depending on the type of wine. In the case of white wines, the main effect was the turbidity decrease, as you can see from this image, and the impact on color and aroma was lower than compared to other additives. In the case of red wines, the main activity was related to the removal of tannin, so consequently the lower and the lower of the astringency and the acidity and the enhancement of the body. In the case of rosé wine, the impact on color was lower compared to the one of the others finding agent included in this study. So every wine shown to be positively impacted by this extract in different ways. Finally, reaching the wine lees, which was the main of my PhD project. The wine lees as large material collected in different steps of wine clarification and aging. Also distilled, so used for the production of distillates and ethanol, but also for the production of tartaric acid. Even in this case, there are some parts, which in the case of wine lees are the main parts, that are not currently sufficiently valorized. I'm speaking about mostly about the yeast biomass, which is present in the lees, that after distillation is usually disposed or in some virtuous distilleries used for the production of energy. And in this scenario, our idea was to try to extract yeast saccharides from this yeast biomass that are the lees. In this first study, this yeast saccharide, mainly manoproteins, were applied in wine to see their impact on the main biological properties related to manoproteins. In this study, we also developed a novel autoclave extraction, which is food grade and was able to yield also fully soluble extract. Unfortunately, the impact on protein stability was not significant, but we had a significant impact on the tartrate stability and above all on the foaming properties, which in terms of height and stability were positively affected by the addition of our manoprotein extract from wine lees. In this second study, we applied a similar extract obtained in the same way in food application. We know that manoproteins have both foaming but also emulsifying activity. So in this second study, we add them to model food system and see their emulsifying activity and foaming properties, comparing them with yeast extract obtained from a pure culture. In both cases, in the case of emulsifying activity and foaming property, we had encouraging result. Particularly interesting was the case of the foaming properties, where significantly high volumes produced with a very high stability over than 3 hours. This slide is about our last study that is still in progress, in which we applied the same similar yeast polysaccharide extract obtained from wine lees as the oxidant additive in wine. We know that some products, yeast-based products, are present and on market and sold for this aim. And so we wanted to see if even our wine lees extract can have such an activity. Here we are just a preliminary observation, but we see that the addition of our extract had a positive impact on the color, and particularly on the lowering of the catechin oxidation. Possible causes can be the presence of polyphenols, glutathione, or the membrane sterols and their oxygen consuming actions. So to finally summarize my presentation, we have seen that basically every byproduct can be used to produce food supplements, which are a best and more sustainable way to manage this byproduct compared to conventional composting or burning. But how do we think that this can be put in place in the industry? First, we don't think that something that could be directly done by a single winery, but we see the need of create a cooperative collection system of the different byproducts in order to lower the variability of the byproduct and at the time increase the standardization of the following extractions, which must be done applying a real industrial approach, able to produce extract in an efficient way and also to sell them to the food and wine industry. So this is our view, but with two big question marks related to the collection and the logistic needed for collect the byproduct from every winery and in a regular way. And also the second question mark is who is able to apply then an industrial approach to produce the valuable extract from the winemaking byproducts. So two questions with possibly one answer, which are for us the distilleries. Here I reported some data on the Italian situation, but distilleries are the ones that already collect a large part of the working byproducts to produce not only ethanol, but also polyphenol, grapeseed oil, energy, and in some cases also fertilizer. And this is reflected, had already positive impact on the environment. In Italy, it was estimated that the activity of these distilleries determine a reduction of 500,000 tons per year of CO2 emitted. So in conclusion, the distilleries are the place where the byproducts are collected. So the logistic is already in place, partially, but still in place. And also they are the actors of the supply chain that pay more the cost of the disposal, like in the case of wine lees, and that they cannot valorize. It's a big problem for them. And we also noticed, talking with some of that, they are very interested in finding new way to fully exploit their byproduct because the valorization is their core business. For this reason, we believe that this ring of the supply chain should be object of more research, and so every byproduct should be studied, for example, in the case of wine lees and grape pharmacy after the distillation, and that this is the point in the supply chain where we can reach the better sustainability for the whole wine sector. Thank you for the attention. I want to thank also all the researchers and people involved in this in the study that I just briefly presented to you, and thank you to the audience for the attention. If you have questions, just contact me or ask me during this presentation.
Thank you very much, Alberto. So very interesting approach. So I think that we will have some comment and question. Maybe we can go through Francisca, and then we can ask question with Antonio and manage the question of the audience.
Okay, perfect. Thank you so much for the presentation, and also for inviting me to share our more recent results. And these results belong to the Raúl López doctoral thesis, and it's titled Wine Lees, a New Source of Antihypertensive Compounds. Sorry, okay. Hypertension is a serious medical condition and is one of the main risk factors of cardiovascular disease. Its prevalence is very high, and according to the World Health Organization, over 1 billion people have this disease. In addition, it suffers by 1 in 4 men and 1 in 5 women. It's a condition in which the blood vessels have personally raised pressure. It diagnosed when the blood pressure readings are higher than 140 millimeters of mercury for systolic blood pressure and higher than 90 millimeters of mercury for diastolic blood pressure. There is other condition called prehypertension, is when the blood pressure readings are between 130 and 140 and between 80 and 90 millimeters of mercury for systolic and diastolic blood pressure, respectively. Nowadays, there are different pharmacological treatments to control hypertension. However, some of them can exert undesirable side effects in some patients. And in addition, these pharmacological treatments are not required or suitable for a prehypertensive patient. So there is a big interest in searching a new alternative based on natural compounds. Among the different natural compounds to manage hypertension, I would like to highlight the role of phenolic compounds. Phenolic compounds are secondary metabolites produced by plants, and it has been reported that some of them can manage hypertension acting in different pathways. For example, inhibiting the AC, AC is angiotensin converting enzyme, is a enzyme very important in the blood pressure regulation. For example, they can exert antioxidant effect or improve the endothelial function. These phenolic compounds are usually obtained from food. However, in the last years, it has been reported that agri-food byproducts can have a big quantity of this phenolic compound, and the use of agri-food byproducts to obtain this bioactive compound is a good way to valorize this byproduct. In this regard, grapes are one of the world's largest fruit crops, and wine industry produces a huge quantity of byproducts. For example, stem, pomades, skin, seed. All of them contain phenolic compound that can reduce blood pressure or improve endothelial function. However, there is other byproduct, wine lees, that also contain a phenolic compound, but until our research, the antihypertensive effect of this wine lees was unexplored. So, considering all this evidence, we hypothesize that wine lees could be a good source of natural compounds with blood pressure lowering properties after the oral administration. And our objective was to obtain wine lees derived products with antihypertensive activity after the oral administration to hypertensive rats and identify their bioactive compounds. We started evaluating the potential of wine lees as a sort of antihypertensive compound. For that, we select 5 different wine lees obtained during the wine lees wine making process using monovarietal varieties, 5 grapes, 5 red grapes varieties, and 1 white grape variety. And these wine lees were centrifuged to obtain the liquid fraction, and after that, AC inhibitory activity was determined in these supernatants. As I mentioned before, this enzyme is very important in the regulation of blood pressure, and in fact, AC inhibitors are the first line treatment in the control of hypertension. As you can see in the table, the red grape variety showed the best AC inhibitory activity, and when it was determined the IC50, IC50 is the minimum quantity of the wine lees to inhibit the enzyme. So the most active wine lists were the wine list Cabernet, Garnacha, Mazuela. So these 3 wine lists were selected to evaluate the antihypertensive effect of them. This is important because an in vitro activity not always corresponds with an in vivo activity. For that, we use an animal model of hypertension, spontaneously hypertensive rats, and these animals were intragastric administered water, that is our negative control, captopril, that is an antihypertensive rat, in fact is an AC inhibitor, and the three different wine lists. Blood pressure was recorded at 0 to 468, 24 and 48 hours after administration in the tail of the animals. As you can see in the slide, on the left is represented in variation in the systolic blood pressure, and on the right, variation in the diastolic blood pressure. So, as you see the blue line, these animals are treated with water, and as you can see, this animal didn't change the blood pressure. However, animals administered captopril in orange line showed a reduction of the blood pressure and was from 2 hours post-administration. And the same result was observed in the Cabernet wine list, as you can see in the graphs. However, in the case of animals administered Garnacha or Mazuela, and this animal didn't change neither systolic blood pressure nor diastolic blood pressure. So Cabernet wine list was the only wine list which exhibited antihypertensive effect. Our next step was to identify the compounds responsible of the antihypertensive effect of this Cabernet wine list. For that, we analyzed the 3 wine lists by SPLC masses to identify and quantify the phenolic compound present in this wine list. As you can see in the table, the Cabernet wine list showed a higher content of phenolic compounds than Mazuela and Garnacha wine list. And these differences were mainly due to the flavanols and anthocyanins families. Specifically, it was observed differences in catechin, epicatechin, different procyanidins, and different malvidins. So, according to the bibliography, this phenolic compound can exert antihypertensive effect or improving the endothelial function. So we conclude that these phenolic compounds are the responsible of the antihypertensive effect of this Cabernet wine list. Moreover, we evaluate a potential hypotensive effect of this Cabernet wine list. We use the same animal design that I explained before, but we use Wistar-Kyoto rat that is the normotensive control of the spontaneously hypertensive rats. So as you can see in the graph, animals administered Cabernet wine list didn't change neither systolic nor diastolic blood pressure and during the experiment, and the values were similar to the found in the water group. So we discard this undesirable effect. So with this result, we can conclude that maybe wine list could be a good source to prepare nutraceutical or functional food ingredient in the prevention of hypertension. However, in all these experiments, we use the liquid fraction obtained from a wine list. However, it's known that the solid fraction of this wine list also contain a huge quantity of phenolic compounds. So our next step was to obtain a wine list enriched in antihypertensive compounds through the release of the non-soluble phenolic compound from the wine list. For that, we use an enzyme acid extraction method using flower shine, and the different compounds containing in the wine list were submitted to hydrolysis during 2 hours. So we obtained a wine list hydrolysate. Also, the wine lists were submitted to the same procedure, but without adding a flower shine. So this is our control. So as you can see, the hydrolysate contain more quantity of phenolic compound in comparison to the control wine list. In fact, we observed that all the families of phenolic compound were released during the process. Mainly in the case of flavonols and anthocyanidins families. The wine list obtained, the hydrolysate, was rich in flavonols and anthocyanidins, and in other phenolic compounds like such as gallic acid, catechin, malvidin 3-glucoside, presanidin dimers, quercetin, malvidin 6-acetyl 3-glucoside, and epicatechin. The next step was to evaluate the reactivity of this wine list hydrolysate. So we tested the antioxidant and AC inhibitory activity. So as you can see, this hydrolysate was more active than the control wine list. And also we tested the antihypertensive effect in animals, in spontaneously hypertension rats. And as you can see, this hydrolysate also contained antihypertensive effect and was more prolongated than the one showed by the wine list control. However, it's important to mention that flower shine it's a protease. So maybe during the hydrolysis there were a release of bioactive peptides. So the next step was to identify different or potential antihypertensive peptide released during this process. For that, we submitted the different components of the hydrolysate to separation by molecular weight or hydrophobicity by SPLC, and we obtained we collected 9 fractions. After that, we measure AC inhibitory activity in these 9 fractions. As you can see on the bottom, 5 of them show a good AC inhibitory activity. So we selected these 5 fractions to be analyzed by SPLC masses. We identified 6 different peptides. 3 of them show AC inhibitory activity very similar to other antihypertensive peptides that are in commercial fermented milk. So we decide test the antihypertensive effect of these different peptides. So what we observe is all the peptides except the peptide 4 show antihypertensive effect. So to conclude, our research indicate that Cabernet wine list and the hydrolysate wine list could be good candidates to be used as nutraceuticals or to be included in functional food, nutraceutical, and food supplement for the mitigation and the prevention of hypertension. I would like to thanks to all the group, nutrigenomics research group, and especially to Dr. Raúl López and Dr. Begoña Muguerza, and also to the funding provided by the Spanish Ministry of Economy and Competitiveness. So thank you so much for the attention. Here is my email if you have that.
Okay, so thank you very much, Francisca, Isabel. So very interesting approach, and so very nice work too. And so now it can be time for a question. Antonio, do you have some comments maybe to begin?
Okay, thank you very much, both of you, for two very interesting presentations, which shed more light and more interest towards the possibilities of producing high-value byproducts from our industry. I would start with a question for Alberto. You mentioned in the end of your presentation, I believe, a mandatory obligation for distilleries to reduce their carbon output. Is that coming from a specific regulation targeting industries, or is it because of carbon tax being applied to the activity of energy-intensive operations?
Thank you for the question. We started speaking with wineries, but finally studying more the supply chain and seeing where the logistic goes. We ended up discussing also with distillers, and our focus on distilleries was related to not specifically for regulation, but because many of them they asked different new way, and some of them are willing to invest in a new way to valorize, especially the wine lees and the distillation. Because it's the only byproduct that represent for them an actual cost for the disposal, and because we have some virtuous example here in Italy that are able to close the cycle by putting also the exhausted wine lees in bioreactors to produce energy and biogas. But there are only one or two in the whole Italian market, because it costs a lot of money, and the dimension does not justify this. So it's more. I think it's more. They ask for they have this need to don't pay more for the disposal of the byproduct.
Yes, but my question was that you refer that they would reduce 500,000 tons of CO2. And what wasn't very clear was, is that something happening if they start to use the system of circularizing the use of byproducts, or is that happening as a regulatory imposition because of carbon taxes, for example, in order to reduce the 500,000 tons?
The data were from the last report of the Italian Society of Distillators, and are related to the actual situation. And so they are now reducing that amount of emission because of their activities, because many of them do not only distill, they also extract, fully exploit the byproduct. And so the data were related to what they were able to achieve until now.
Okay. Okay. One other question. Quite often, this valorization gets blocked by logistics problems, and you highlighted that in your presentation. The fact that you have to transport the byproducts from the wineries to the refineries or the processing units. The fact that you have a lot of small-scale wineries where you actually do not see a lot of benefits in doing this type of approach. You mentioned that this could benefit from a collective approach by wineries. Do you have some examples of that happening? Is that happening in Italy, for example, with cooperatives? Are cooperatives getting together in order to address the valorization of their byproducts?
Yeah, unfortunately, it's something quite spread, at least at the Italian level. We have some big cooperatives of wineries that also have their distilleries. And so we have a big example in Emilia-Romagna of this approach, where big cooperatives are able to establish also a distillery, more thinking about a biorefinery. But this example, I think, remains the only big one in it. For all the others, we believe that it's better to exploit what is already in place with the distilleries and work with distillers rather than winemakers.
Okay, and do you think that you see distillers willing to become biorefineries? I mean, to diversify in the way they work and move beyond distillation onto a more comprehensive use of all the raw matter that they have and also the byproducts that they produce?
Yeah, surprisingly, yeah, at least the one that we had the occasion to meet, we discussed with some big players and also the Italian Association of Distillers, which surprisingly, even for us, they were really interested in finding a way to fully exploit their byproducts. So also, yeah, we had a good feedback, and we hope to continue working on this path.
Okay, Pierre, I don't know if you have any questions. I have a couple for Francisca, but you should come in as well.
No trouble. Thank you, Antonio. I have 2 points here at least. One is concerning the verjus, because you were mentioning that it was an interest for people that dislike acetic acid, or maybe that can replace also citrus extract. So the point is that in verjus, well, of course, there is no acetic acid and maybe no citric acid. So is it more pleasant for the people because of the acidity composition? Finally, do you have an idea of the acidity composition in comparison? Normally, it should be probably a lot of malic acid inside, no?
Yes, malic and tartaric acid are the main one. So it's very acidic. For example, in the work in which was applied as acidifying agent for pickled cucumbers, and even if it was according to data, the more acid compared to the vinegar, the cucumbers were perceived as less acid, and this according to the panel, and so this can be related to the less to the volatile viscosity, but also some data highlight that consumers were able to perceive more the taste of the cucumbers. So it's not only for people that dislike vinegar, but it can also determine a quality difference in a more broad sense, make a difference.
So finally, it means that we can have some replacement of kind of, well, of acidity with malic acid, replacing probably acetic acid and also citric acid. So probably.
Yes, that's what.
In terms of potential. And the second point is concerning the mention of extraction, because what finally, what can be a good order of extraction, because there is a lot of different type of products that we can obtain, and is there a real order that is better than some other to process, in fact?
Yes, in the case of wine list, which is the topic where I'm more worked on, we at the moment we believe that we first have to extract ethanol and then tartaric acid, and with what remains, try to apply the polyphenol. Polysaccharide extraction. In the case of Lis, we're now thinking that for our application, the polyphenols can be extracted and present in the polysaccharide at the end.
Oh, okay.
So because we noticed that monoproteins are pretty stable, but yeah, this is something that we are still seeing.
Okay. We have one comment of our colleague Enrico Peterlunger. Enrico, hi Enrico, and so he's saying a curiosity in Italian Renaissance cuisine, the juice of unripe grapes was very used with the name of agresto. You know about it?
Yes, this is the way how it's also known also today. But we have different names for every winemaking referring to more or less similar product, maybe produced in different ways. But this activity of trying to exploit this byproduct, started since ancient times.
Yes, some colleague and Matteo Marangon is saying that in fact the verjuice is being cooked and partially concentrated, in fact, in this case. And there is some other name in different places, like Agraz in Spain, Korkuk in Turkey, Verjus in France. So, well, you see, there is some possibility probably there because of this story, well, this point about acidity. Thank you, Alberto. So maybe we can also have some exchange with Francisca Isabel. So Francisca, I was impressed about the work. It's very interesting. Maybe one first point, it's concerning the norm for hypertension, because I had some exchange with some medical doctor telling me that it looks like the norm are reducing actually in terms of systolic blood pressure, and also, well, especially for the systolic blood pressure, that it should not be not anymore 440 millimeter of mercury, but that it should be 130. Do you have information about this?
Well, yes. There are hypertension can be observed, or there are different types. It can be hypertension due to an increase of systolic blood pressure, or other by an increase of diastolic blood pressure.
Yeah.
So the product that we tested is good because it can act directly over the systolic and the diastolic blood pressure. So it's very good for that. Here we are using animals that have a very, very high hypertension. It's a very potent grade. Because, for example, a normal rat can have over 120 millimeters of systolic blood pressure, and this animal has 200. So here, what we are seeing is a very potent reduction. But for example, we tested also this Weinleys in other animal model of hypertension. Is a model that develop hypertension with the diet. So it's very similar to the hypertension that human has. So in this model, the reduction of the blood pressure is lower. It's about 10 millimeters of mercury, so it's normal. So you said in human, for example, a reduction only of 5 millimeters of mercury of systolic blood pressure is related with an improvement in cardiovascular risk factor, for example. So.
And do you know how it works? Because, for example, for a pharmaceutical, we know that there is anticalcic, or for diuretic possibility. Well, there is several possibility, in fact, of action. Do you have an idea of the action? Because finally, you mentioned that it was a combination. There is phenol and there is peptide. So how they act? What can be the mechanism there?
Yeah. It's a good question, and in fact, we evaluate the different mechanisms involved in the antihypertensive effect. Not in the hydrolysate, but yes, we did in the Weinleys liquid fraction. And in this case, we observed that there were an improvement of the oxidative stress. We saw differences in the production of glutathione, reduced glutathione, that is an important antioxidant in our body, and a reduction in malondialdehyde, that is involved in oxidative stress. Also, we observed that there were an improvement of the endothelial function. First, the endothelium plays an important role in the regulation because the cells produce different vasodilators and vasoconstrictors. And in the hypertension, there is an imbalance between these two factors. So the Weinleys liquid fraction produced an improvement of well, we saw gene expression, so no protein, but we saw that was an regulation of endothelin, that is a vasoconstrictor, the regulation in NOX4 is an enzyme that produces reactive oxidative species. Upregulation of, remember, INOS. Yes, INOS is important enzyme that produces nitric oxide, that is a vasodilator.
Okay. Okay, thank you. Antonio?
Yes, thank you. Francisca, I'm interested in understanding the potential of your discoveries in terms of the business that it may help. So, my first question is: would it be possible to have a kind of food supplement made from the extract, the leaf extract itself, without separating the compositions, because there seems to be a synergical effect between the polyphenols and the peptides, and you were able to demonstrate that the actual use of the Lee extract would already lower the systolic pressure. So my first question is, could that be a way of doing it from an economically efficient point of view, to just go from the Lee extract directly to the food supplement without further extraction? And the second question is, how competitive is this source of these nutrients against other types of sources, other types of fruits or foodstuff that also have polyphenols and this type of peptides?
Mm-hmm. Okay. I don't know. I don't know if I understand you about the first question.
I can, if you want, I can rephrase it.
No, it's not necessary. It's because when you said further separation, I don't know if you said about separation between liquid fraction and solid fraction, or between polyphenols and peptides, for example.
Yeah, between polyphenols and peptides. But what I mean is, can we have the same effect without doing anything else but just to have the Lee's extract?
Yeah. In fact, you don't need to elaborate the hydrolysate. All the wine list only for the phenolic compound that has an important antihypertensive effect. So you don't need to do anything more, separation or anything more. And about the second question,
it's how does it compare, the activity you have found from grapes? How does it compare with other fruits and other sources?
Well, our group has very experiences in working in GSP, that is a grapeseed preservative extract. In comparison with these products, it is better the wine list hydrolysate, because we observe the same more or less results using a dose of 375 milligrams of GSP, and here we are using 125 milligrams, so it's better.
Okay, that really seems quite interesting. We have also a question from Mateo Marangon in the chat. He is asking you about your opinion on whether other wine list components, like for example beta-glucans, could also have some beneficial health impact.
Yeah, could be. I don't know working in other compounds, but it's possible that there are other components bioactive in the wine list.
And are you thinking of exploiting those other compounds as well in your research? Are you looking into other compounds?
Well, we work with a winery that is very interested in do something with the wine list. Yeah.
Okay, thank you. Yes, Louis?
Well, very nice, very interesting approach. Well, my own lab is working also on hypertension, but with stems for a long time and some phenol. But globally, we have, well, the same approach, but not exactly with the same product. So that's also an interesting approach to see maybe if the yeast can liberate some compounds, in fact, finally in the yeast, that can be of interest in the effect, in fact. So that's also one of the points. Okay, I think that I don't know if there is some other question. I think that I don't
think we do.
I don't see some other, but in this case, maybe we have to finish to close the symposium, because it's we have passed already 1 o'clock, almost 1:10, and so really it was a very interesting approach. We can think maybe to have some project about the valorization of co-product after the winemaking or before in the network, and this can be really a very exciting to see what can be developed because it looks like that there is a lot to do for a new potential product for the valorization and for our industry. So thank you to all. Thank you, Antonio, for managing. Thank you, Agathe, for preparing. Thank you, of course, to Alberto and Francisca Isabel.
Thank you.
It was a great pleasure, and so we hope to see you in our next events. Probably during May there will be a symposium and general assembly that will be online, and so we will send information to all of you. So thank you very much to all, and bye bye.